Okay, so we're on Unit 2, and the topic is the operating system. An operating system is a set of instructions that controls the execution of applications. Examples of operating systems are Windows platform, Unix, and Mac. Operating systems allow interaction between the application and the hardware. The operating system uses the hardware resources to provide various services to users. Okay, so there are different platforms of this operating system, and the most widely used one, or the industry standard platform, is Microsoft Windows. Okay, so Microsoft Windows, it strikes a balance of convenience, okay, and affordability. Okay, so we also have Linux and Mac, but Linux is not, you wouldn't categorize it as convenient to use, but it's definitely more affordable than Windows. In Windows, everything, so they have to get a license for everything, which makes it a bit expensive, okay? As opposed to Macs, Macs are a privilege, everything about the Mac, including the hardware itself and the whole operating system is just expensive. Okay, so we see all of these operating systems on these different platforms, but the concept we're going to talk about today is basically independence of a platform. So for as long as it's still an operating system, the concept that we're going to highlight will apply to it. Okay, so we are going to cover the following learning outcomes: describe operating systems, list and explain the functions of an operating system, discuss evolution of operating systems, define virtual machines and virtualization, discuss the basic structure of Windows, explain the features of Unix systems, and explain the various layers of Android. Okay, so we said that this software, because it's still a software at the end of the day, but it's a software suite, which means it's a software that brings other softwares in it. And we noticed that when we actually install an operating system, before we can even install our own personal applications on it, it already comes with built-in applications with it. For that sense, we refer to it as a program or a suite of programs, okay? And it says frequently relinquishes its control and must depend on the processor to allow it to regain control. And the operating system has a way of sort of compromising itself to improve performance or user experience. So maybe if you're running low on memory, you're going to see that the operating system is going to sort of reduce the graphical user interface for you to be able to optimize the performance or use the CPU at its optimum performance, okay? So there is this concept that we refer to as serial processing. And this, we normally found this in very early version computer system, okay? So serial processing means transactions and functions are performed in series or in sequence in a linear manner, one after the other, okay? So earliest computers with no operating system, programmers interacted directly with the computer hardware. Computers ran from a console with display lights, toggle switches, and some form of input device and a printer. Users had access to the computers in series. Okay, so this is very early version. There was no fancy graphical user interface, and these people who use computers used to punch in commands using some sort of input device on a console, and then there was an output device, a printer printing on the other end, which it was an improvement of the manual way of doing things. One can agree it was definitely an improvement because now you are using a computer to do your work for you. But there was room for improvement if you're comparing it with what we have today. Okay, so series processing it's a good improvement on manual systems, but it is not it's not efficient. So why then do operating systems exist? Okay, we say they are convenient. The operating system allows the users to interact with the computer in a more friendly way. Users are able to interact with the system through interfaces. So instead of punching in commands on a console or on a command utility, okay, what happens is you do that through wizard screens and interfaces. And all operating systems provide that convenience. Even Linux, there is a version of Linux which is made to be very graphical. So any person who wants to use Linux on their computer may do so. And then there is the versions of Linux that are very technical, and you have to use the command to perform even the most common tasks. And then they also say efficiency. The various resources of a computer can allow users to interact with the system in an efficient way, okay? And so the operating system is also in charge of managing these system hardware resources. And in the next study unit that we're going to cover, we're going to talk about how the operating system actually helps with the management of the memory or the RAM in the computer. Okay, so it's an efficient thing because it's a software that also allows for efficient management of system resources between the various programs. It has the ability to evolve. Okay, so the industry or the hardware manufacturers, so people who manufacture graphics cards, CPUs, memory, they're constantly improving on the architecture of their hardware, which means as well, the operating systems have to evolve to take advantage of those capabilities. Okay, so the operating system is also bound to evolve. So some of the common features that are performed on an operating system, we say it's performing common hardware functions, okay? Management of hardware that you've plugged in. You're able to see all the different devices that are plugged into your computer internally, okay? What is the hard disk space? What is the memory space? What is the speed of the CPU? Providing a user interface, which we already mentioned, it makes it more convenient for you. Communication, okay? So through the operating system, we are now able to implement networks. Okay, you can't implement or roll out a network without an operating system. So thanks to it, then now we can now sort of get devices communicating with each other. And also device management, the operating system manages devices using device drivers. So anytime you want to plug in be it a flash drive or whatever kind of device, the operating system will be able to detect it for as long as the drivers have been installed for that particular hardware. And then at your own discretion, you can choose to go to Device Manager and you can enable and disable certain hardwares when they are no longer in use, okay? So that's the brilliance of it in terms of device management. And then you also have file management, okay? So thanks to operating systems, we now locate our files in a more organized manner, in a more organized structure using the file system, okay? We use what we call directories and files have to have extensions and so forth, which actually brings us to our next slide, because file systems are found on long-term storage, which is secondary devices. So any secondary device with an operating system would have a file system. And a file system basically determines the partitions we have, the folders, okay, the folder structure, and the different file supports, okay, extensions. So what kind of extensions does the file system work with? Okay, we know for Windows, if you wanna install a program, the extension must be a .executable. So that is all facilitated by the file system, okay? So file systems exist because they enable us to retrieve or define how data or files are stored and retrieved on the operating system. But they also have an added advantage because they enable us to protect files from unauthorized access, okay? And that's in our next slide, access control to resources. So you plug in your flash drive, you put a file on your desktop, okay? That is done through your user account, so you become the owner of that particular file, okay? So the file system will say, who created this file? And the person who created it will be assigned full control permissions over that file, which means they can modify, they can read, they can do whatever. But someone else who wants to make changes to that same file might not be able to if they're not granted those permissions. So the other good thing about the file system is that it allows us to hide confidential files and stuff like that, and put and set permissions on them so that we forbid users that are not supposed to get access from having access to be able to open those files. Okay, so we say that operating systems evolve, which is something we mentioned earlier, but why do they evolve? Okay, they evolve due to upgrade of hardware. And they say graphics terminal can be used to provide various applications by users. To accomplish this task, an upgrade may be needed. Okay, so may I just ask whoever has the mic on to mute themselves, please? Because I can hear feedback from your mic. I think it's you, sir. I may need to mute you. Okay, so operating systems evolve and change due to changes of hardware manufacturers and so forth, or upgraded hardware. You know, Microsoft is always sending you updates. Why? Things have changed. Things have changed in the world of technology. So they're always sending new updates or patches or whatever to be compliant and support additional vendors, okay? And the second point they say, operating systems evolve or change because of new services, the provision of new services. Picture cloud computing. Cloud computing wasn't there the time we had Windows XP, for example. Now we're on Windows 10, and you can sort of do everything through Office 365 or the cloud. You can synchronize your Microsoft Word applications to the cloud. So it means then that from the time we moved from Windows XP all the way to Windows 10, there has to be some sort of evolution for this operating system to be able to support the addition of new services. And then we also have fixes. So the operating system might have faults. These faults can be identified over the course of time, and fixes are made. One of the factors that cause people to actually move to Linux is because they see Linux as a more stable operating system in terms of security, as well in terms of the number of bugs or faults. Okay, so people tend to gravitate towards Linux for those following reasons. Microsoft is still very much criticized for having too many bugs and too many viruses and so forth. So we constantly see the evolution of operating systems due to fixes. Vendors or software vendors may need to implement patches if they identify any new threats. So the next concept we're going to talk about is the monitor, also referred to as the resident monitor. Here, I'm not referring to the hardware monitor, okay? I'm referring to a program or a software that is referred to as the resident monitor, okay? So what does it do? So before we coined the term operating system, there was something already existing. And earlier on, we talked about a computer that processes information in series. It needed some sort of operating system. but we couldn't call what it had back then an operating system. It wasn't a fully fledged operating system for the mere fact that it didn't do the tasks that we just highlighted, that sort of operating systems, the functionality that operating systems give us. They didn't give us that functionality, so we couldn't categorize the monitor as an operating system, but it definitely it was something that served the same purpose back then. Okay, so this resident monitor, what it does is it sits, as the computer boots up, it will sit there in the main memory and it will reserve a certain portion of the memory for itself. Okay, and they say here that monitor places a job in the user program area. Monitor controls the sequence of events. Resident monitor is software always in memory. Monitor reads in job and gives control. Job returns control to monitor. So you can see that its role is to coordinate other programs in execution. And for that mere fact, we can say it's playing the role of some sort of lightweight operating system. And what does it do? It installs a suite of programs that manage, okay, that manages device drivers, that manages the sequence of jobs, that control language interpreter. Okay, so common task, and this term has been replaced by another term which we say it's a kernel. Okay, so now we no longer refer to it as a monitor, we refer to it as a kernel. You may have heard of the Unix kernel and the Windows kernel. Windows kernel obviously used by Windows operating system. When it comes to the Unix kernel, it has been adapted by other operating system manufacturers such as Apple and Linux and Android. All of those are built on the same architecture, which is the Unix kernel. So the kernel is what we find in modern day operating systems, but before we refer to it as the resident monitor. And I think the term resident is very significant because it resides in the memory. So when the computer boots up, it's the first thing that will place itself there. Although we say it permanently put itself there, but we know because it's memory, nothing is permanent. So it sort of happens at runtime. So what do we mean then by user program area? So since the resident monitor will reserve a portion for itself, it means the leftover portion of the memory will be reserved for any programs that the user wants to execute on the computer. Okay, and I will be making reference to this. So I really do need you guys to be able to grasp the concept, because for the slides that follow, we're going to be making reference to this one. Resident monitor, you can see it takes a portion of the memory for itself, and it has a couple of programs that it installs, interrupt processing, device drivers, job sequencing, control language interpreter. And then we have the user program area, which is whatever is left over. And when you execute a program, this is what this is the area or the memory allocation that that particular program would have to use. Okay, so we've moved from serial processing computers, and we said serial processing is not sustainable for the mere fact that things happen in sequence, one after the other, immediately after the other. So we needed a more convenient way, okay, or more efficient way of improving the execution of transactions or processes on a computer. So we have simple batch systems, we have uniprogramming batch systems, we have multi-programming batch systems, and then we also have time-sharing systems, okay? So let's compare these different concepts as they relate to the operating system. So a batch system, forget the term simple, but what is a batch system and how does it differ to a serial processing system? A batch system is something that processes tasks or transactions in batches. So we tend to see this a lot in retail stores. Okay, you can imagine in a retail store if they were doing serial processing. It means if there are 1,000 transactions performed in a day, it means those different systems, the bank systems and the retail store systems, they literally processed 1,000 transactions a day. Every single time someone is paying, they need to process a transaction, and it's going back and forth between the server. So somebody comes and wants to use their card to pay for a 10 Rand chocolate. How much is the retail store going to pay to facilitate the transaction? So what is a more convenient way of doing this? It means we put every transaction into a pending state, and then at a convenient time, most likely at the end of business day, we process the transactions as a batch. Okay, so batch systems, simple batch systems, are an improvement definitely on serial processing for the mere fact that it's more efficient. Things are done as a group, as opposed to just one after the other sequentially every single time. Okay, so there's nothing really complex about those systems, but besides the fact that they process things in batches. And then we have our what we refer to as our uni programming batch systems. Okay, so it says input-output operations are exceedingly slow, okay, compared to instruction execution. A program containing even a very small number of input-output ops will spend most of its time waiting for them. Hence, poor CPU usage when only one program is present in memory. So what do they mean by uni-programming? So in a uni-programming batch system, okay, what would happen is that the programs will sort of be sent to the memory one at a time. Okay, it will be sent to the memory one at a time. Earlier on, I showed you the slide of the resident monitor. You can see here that there isn't no resident monitor, but there's what? There's the OS. Okay, so there is the OS already taking up memory. Okay, it's taking up a certain portion of the memory for itself, which means the leftover part is what we call the user program area. So in a unit programming system, we can only have one program at a time in this area. So if that program's capacity is not even using up the whole capacity of the RAM, it means then we have memory allocations wasted because these other programs are sitting here outside, okay? But they can't go in two at a time. We have to do it one at a time, okay? Which is inefficient. So let's say program one then goes into the user programming area of the RAM, and then the CPU starts to attend to its functions. Okay, now what could happen is that program one decides to do an interrupt, okay, or the printer decides to do an interrupt, or because program one initiated it, it wants to print. So program one wants to print a document. So what would happen is that there will be an interrupt request to the CPU to tell the CPU to wait, okay? So the CPU will wait while the program is printing. It's in its idle state, okay? So once the program is done printing, then the CPU takes over again. So can you see the problem that we have here? Is that while program one was not using the CPU and was using the input-output process of, or whatever, printing, okay? Another program could have utilized the CPU while it was in its idle state. So unit programming systems, it's poor usage of the CPU, okay? For the fact that we can only have one program here in this user program area of the memory at a given point in time. And we can compare that to the multi-programming batch system. And we tend to refer to this as multitasking. That's the term we use in this modern day and age. So we say we're multitasking. We're opening up different programs on our computer at the same time. Okay, so that is thanks to advancement in technology and multi-programming systems. Okay, and so how this works is that in a multi-programming system, program 1, program 2, program 3, and program 4 will all go into the user program area of the memory at the same time. And you can see here that the OS is already there hogging or taking up its portion of the memory. So if program 1 is using the CPU and then program 1 decides to print, okay? So the input-output request will cause the CPU to wait. While the CPU is waiting for program 1 to finish whatever it's doing, program 2 can now use the CPU because it's in its idle state. So can you see the efficiency compared to a uni-programmed systems, okay, that we find in multi-program. So this concept is referred to as multitasking. And in this slide, basically, they're just outlining what are some of the significant differences that you're going to experience when you compare a multi-programming system to a uni-programming system. So what I can say, to sum up what you see here, the numbers you see in front of us, is that definitely in a multi-programming system, there's going to be more throughput. So there's going to be a higher throughput rate. You're going to do more because you're executing things simultaneously. Okay, so there's going to be more jobs done within a given limited time frame. However, a multi-programming system will definitely require more or heavy use of resources. When I say resources, I mean it will require bigger memory because all the programs will be there present at the same time. It will require disk space, more disk space, it'll use the printer more often because there's a lot of programs there at the same time. It will also push the processor to its limits. Okay, so you can see you're investing in additional resources, but you're also getting a higher throughput and efficient use of those resources in a multi-programming system. And again, this is a concept that is demonstrating the concept of multitasking. We have three different jobs: job 1, job 2, and job 3. We say that job 3, type of job, heavy compute. How much memory does it require? 50 megs. Okay. What kind of resources will job 1 use? Will it use the hard disk? No, it won't. Will it use the terminal? No, it won't. Will it use the printer? No, it won't. Okay. Let's compare that to job 2. So job 2, type of job, it's heavy in terms of input-output request. Okay. How much memory would it require? 100 megs. Would it be using the hard drive? No. However, it's going to be using the terminal. Okay, it's going to be using the printer? No. Okay, then we go to job 3 and we see job 3 is also heavy in terms of input-output requests. Okay, how much memory does it require? 80 megs. Will it be using the disk? Yes. Would it be using the terminal? No. Does it need the printer? Yes. This is a perfect example of jobs that can be executed simultaneously without conflict, because as you can see, in terms of the resources they require, they're not contesting for any resources. You see, job 1 doesn't use any resources. Job 2 only uses the terminal. Job 3 uses the disk and the printer, but not the terminal. So here it's perfect execution of transactions that we can execute at the same time without any conflict. And then we also have time sharing systems. Okay, so I think this is what we find in modern operating systems, and time sharing systems provide the convenience of the earlier evolutions. Okay, so this is the highest evolution of the operating system in terms of time sharing. So what do we mean by time sharing? It says that Time sharing, batch multi-programming does not support interaction with users. So time sharing system extends multi-programming to handle multiple interactive jobs. And I said this before, I said in terms of technology in computers, there's always room for improvement. So they identify that although a multi-programming system it has its advantages over uni-programming in terms of efficiency, but there's room to improve it because there's no human interaction. So the whole time in a uni-programmed system and a multi-program system, there is no direct human interaction. What I mean by that is the transaction is started, initiated at once as a batch, okay? And then to the end state where it finishes whatever it's doing, there's no human involved. The only time a human is involved is when they click start and the job does everything by itself and then it finishes at the end. So what does time sharing mean? Time sharing means things happen in real time. Okay, it means now that the computer, which we tend to refer to as the server, is doing multi-programming, but in real time. So all of these users, as you can see here in the diagram, they're sitting in front of the computer, they're interacting and they're sharing the CPU in real time. Can you see now it's happening dynamically? And there's going to be more pressure obviously put on the CPU for the mere fact that the people are doing that in real time, so they can execute as many programs as they want, but they're sharing. So the more you tend to open up and execute, then you're going to see that the performance is going to tend to drop. So one other thing is with the time sharing system, there is a need for implementing a proper file system that protects files from being accessed by unauthorized users. Okay, because unlike uni-programming and multi-programming systems where it was an automated task done by the computer without human interaction, here it's an interactive system and people are sharing processes, sharing hardware resources, sharing disk space, sharing printers. There's going to be conflict, there's going to be access to data, so you need some sort of access control, and the file system will allow you to do that. Okay, so modern operating systems take advantage of the concept of time sharing because they are interactive. And then the major achievements to meet the difficult requirements of multi-programming and time sharing, there have been 5 major achievements by the operating system. So the operating system has improved the way it actually executes a process. Okay, there is better memory management, which we'll discuss more in detail in the next study unit we're going to cover the next time I see you. And there is better information protection and security, okay, for reasons that are highlighted in the previous slide, because there's going to be multiple simultaneous access to the same data. Scheduling and resource management is improved, and also the system structure is also greatly improved. And the last concept that we're going to talk about is the concept of multi-threading. Okay, so modern CPU architectures allow for multi-threading. So what would happen is that the CPU will break a program into threads. Okay, so we've gone a step further because we said with multi-programming, multiple programs within the CPU at the same time. But now with the concept of multi-threading, we can further optimize this and say we can break up the program into multiple threads itself. And we can make use of the capabilities of multi-core processors and parallel computing. I just want to move to the next slide, which is a diagram version of what I'm talking about, and it will help you better visualize the concept of multi-threading. So if a program is broken up into threads, and we're assuming that this is a multi-processor computer, which means it's a computer with multiple physical processors inside. Multi-threading would allow the different threads of the computer to go to the most available processor. So if processor 1 and 2 is busy, then processor 3 can execute the threads. So there's multiple routes to the destination. Okay, so we tend to see multiprocessor systems in server machines. It's not so common in end user computers. So the computer you have in front of you now is most likely running a single chip. Okay, but it doesn't mean that single chip or home computers cannot use the concept of multi-threading. The fact that we have a multi-core processor, one physical chip, but with multiple cores in it, it means that we can implement multi-threading because the threads will sort of bounce back between the various cores of that particular CPU chip. Okay, so that's unit 2, and the focus here is operating systems. What kind of advantages do they bring to the concept of computers? And you can see that the major advantage is efficient use of computer resources. Okay, so I'll just in the remaining time I'll give you an opportunity to also ask questions if